All right, the next part of the lesson is to teach you your new derivative rule today, which is your product rule. And it's when you have two functions multiplied by each other. Okay, to take the derivative, you're going to do the first times the derivative of the second, and then add it. It's plus. People tend to forget the plus. The second function times the derivative of the first. You need to remember that phrase, remember this pattern. And it is a product, so the order doesn't matter, but it's a lot easier for you to stay consistent and just choose whichever function you define to be first. Just memorize this phrase because it's going to be easier to stay consistent. Okay, so this very first one, we're going to say f of x is e to the x. So f prime of x is also e to the x. G of x is going to be sine x. So g prime of x is cosine x. Your rule says h prime of x is going to be f of x, g prime of x, plus g of x, f prime of x. So I'm going to substitute in. So that's going to be e to the x. This is my first times the derivative of my second, which will be cosine x, plus the second, which is sine x, times the derivative of the first, which is e to the x. Now, it's bad form to leave it like that, so you're typically going to see it as either e to the x cosine x plus e to the x sine x. Occasionally, you will see they tend to factor out e to the x on your AP answers, so that could also be e to the x cosine x plus sine x. Either of these last two answer choices would be common answer choices. Okay, that one's a little hard to see because the derivative of e to the x is e to the x, so we're going to do another example. In this case, we're going to say f of x is x to the fourth. So f prime of x is 4x cubed. And g of x is going to be cosine x, so g prime of x is negative sine x. And I'm going to put it together. H prime of x is going to be the first times the derivative of the second plus the second times the derivative of the first. And then I'm going to clean it up. You wouldn't leave, you move the negative out front. You wouldn't leave the negative as a product in the parenthesis. You're not going to get penalized for leaving the answer in this form, but you would never see a multiple choice answer that looked like that. So it would be negative x to the fourth sine x plus 4x cubed cosine x. All right, and the next part of this is, if you notice, I've got two functions, and then I'm asking it to take the derivative of the product of those two functions at x equals 2. This is typical function notation where it's all kind of in code. This is really telling you you need to use the product rule, okay, which is going to be f of x, g prime of x, plus g of x, f prime of x. And the thing is, and this is at 2, I always encourage you to do the generic. I'm going to consider this, I'm going to call this rule kind of like you would expand a logarithm. If you'll expand it in the generic form, then you're less likely to mess up, because most of the time what happens is people multiply and substitute in too early without using the proper rules, and they end up with the wrong answer, and it's usually one of the answer choices that's on a multiple choice. So f at 2 is 2, g prime at 2 is negative 3, and then g of 2 is 4, and f prime at 2 is 5. So this is going to be negative 6 plus 20, so that's going to be 14. And you can see that if you didn't expand it in its generic form, you're going to not get that answer at all. Okay, we're going to do another one. All right, so I'm going to say, without writing the rule out, I've used f of x this time, but I'm going to go ahead and say it's the first So it's x squared plus 3 times the derivative of the second, which is 3x squared, and then 1 goes away, and then plus the second, so that's going to be x cubed minus 1 times the derivative of the first, which will be 2x. Okay, I'm going to distribute that, so it's 3x to the fourth plus 9x squared plus 2x to the fourth minus 2x, and that ends up being 5x to the fourth plus 9x squared minus 2x. Before I knew the product rule, I didn't know any other way to do this, but there is another way to, I did know another way to do this. So I'm going to show you another way to do this, and that's going to be by going ahead and multiplying the original function out. So I'm going to FOIL it out. So that would have been x to the fifth plus 3x cubed minus x squared minus 3. And if I take the derivative of that, I get 5x to the fourth plus 9x squared minus 2x. My answers are the same. If you take the derivative of two different things and get different answers and they don't simplify to be each other, then you've messed up somewhere. Okay, I'm going to give you a preview for the quotient rule, and we're going to deal more with the quotient rule tomorrow. The rule with the quotient rule is you have a function on the top and a function on the bottom. You're going to do the bottom function times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Now, I cannot make this up. Well, I can make this stuff up, but I did not make this stuff up. This is kind of like SOHCAHTOA. Everybody thinks it's completely ridiculous the first time they hear it, but then you see it over and over again, and people will use this rule to remind themselves how to do the quotient rule from henceforth. There's two different phrases that you can use. The first one is bot der top minus top der bot, and the der stands for derivative, over bot. And for some reason, that really helps people remember it. The other way is ho d high minus high d ho over ho. Okay, either one of those phrases, I don't care. I don't care if you use them at all, but there are a number of people that find them to be very, very useful in helping to memorize this rule. And we're going to do a couple of problems with the quotient rule, and then we'll do some more practice with that tomorrow. Okay, so my top here is x to the fourth, so its derivative is 4x cubed. The bottom is x squared minus 1. Its derivative is 2x. So it's going to the bottom, bot, x squared minus 1, der top times 4x cubed minus the top times derivative of the bottom over x squared minus 1, bot, quantity squared. That's what your derivative is equal to. Clean it up, distribute combined like terms. You're going to get 4x to the fifth minus 4x cubed minus 2x to the fifth. Just leave the bottom squared, x squared minus 1, quantity squared. So that's 2x to the fifth minus 4x cubed over x squared minus 1 squared. All right, and then one more example and we'll be done for the day. So I'm going to say f of x is sine x, f prime of x is going to be cosine x, g of x is x, g prime of x is just 1. So the bottom, bot, so h prime of x, the bottom is x squared, x times cosine x minus sine x times 1 over x squared. Okay, maybe not so impressive, but if I want to take the second derivative, that's going to be the bottom times the derivative of the top which is going to be, let's see, x bottom times the derivative of the top. So this is product rule. So it's going to be the first times the derivative of the second plus the second times the derivative of the first, which is just going to be 1, and then first times the derivative of the second, second times the derivative of the first. I'm still on the top, minus cosine x. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So it gets a whole lot messier as you go on.